Hello students, it's Miss Nares, and today's video is about the fundamental counting principle, which sounds fancy and a little complicated, but really many of you have already figured this out. It says that if there are p ways to do one thing and q ways to do another thing, then there are p times q ways to do both things. So basically, I'm going to be doing a lot of multiplication today. Here's the first example. For breakfast, students could pick a burrito, a donut, or croissant. Then they can take fruit or not. And finally, they get to pick milk, orange juice, or apple juice for their drink. How many possible outcomes are there? I could make a tree. I could make a list and then count them all up. But the problem doesn't want the sample space. It's just asking how many are there, how many possibilities. So I just have to multiply. Now, there are 3 different things that the student has to pick. They have to pick their main food, which they have a choice of burrito, donut, or croissant. So that's 3 choices. And then they have to decide if they want fruit or not. So that's 2 choices. And lastly, they have to decide between milk, orange juice, or apple juice. So that's 3 choices again. I do the multiplication. 3 times 2 is 6 times 3. Okay, I got 18 possible outcomes, 18 different breakfasts that a student could pick. Now, if I was interested in how many of them have milk, if I just wanted to know how many of the breakfasts include milk, then I'm going to change these numbers a little bit. Their main dish, they still have 3 choices. For fruit, they still have 2 choices. The only one I'm changing is the drink because now I'm only asking for milk. So instead of having 3 choices, they would only have 1 choice. I do the math again. 3 times 2 is 6 times 1. So 6 out of the 18 have milk. Now, if I simplify that fraction, 6 out of 18, the same as 1/3. So 1/3 of the breakfasts would have milk in them. Let's do another one. Example 2. A computer randomly generates a new 5-digit passcode for a warehouse door each month. How many passcodes are possible? And then how many of them start with a 3? Well, it's randomly choosing the 5-digit passcode. So the computer has to decide 5 things. It has to decide what the first number is going to be, what the second number is going to be, the third, the fourth, and the fifth. And then I'll just multiply everything together. Well, for the first number, the computer could pick 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0. So that's 10 different choices. For the second number in the passcode, it still has 10 choices. For the third number, it still has 10 choices. For the fourth number, it still has 10 choices. And for the last number, it again has 10 choices. If I multiply that together, I get 100,000 possible passcodes or passwords. So if you were going to try to guess it without any information, there are 100,000 different passcodes that it could be, and it would probably take you a long time to randomly guess what the passcode is. Now, let's say that you knew the first number was a 3. How many of the passcodes start with 3? How many different things would you have to possibly try? Well, I'm only changing the first number. It says how many start with a 3. And I'm changing that first number to 1 option because I'm asking for the first number has to be a 3. There's no choices there. But every other number, I still have 10 choices to choose from. If I do that multiplication times 10, I have 10,000 different passcodes that start with a 3. Final example. Example 3. In how many different ways can Alice, Becky, Carl, and David place first, second, and third in a race? So these 4 kids are racing against each other. How many different ways could first, second, and third come out? Well, again, there are 3 choices here, or 3 things that have to be decided. First place has to be decided, second place, and third place. Well, how many choices for first place? Well, Alice or Becky or Carl or David could all win first place. So 4 times, now I'm going to do second place. 4, wait, it can't be 4 because once somebody wins first place, there's only 3 people left racing. So For second place, I only have 3 options. I don't know what the options are because I don't know who's won yet, but there's only going to be 3 people left. And similarly, for third place, after someone wins first and someone wins second, there'll only be 2 people left running. So that's 2 options for third place. If I go ahead and multiply that out, 4 times 3 is 12, times 2 is 24 different ways for Alice, Becky, Carl, and David to finish in first, second, or third place. So it could be like Alice, Becky, and Carl, or it could be Becky finishes first, and then Alice, and then Carl, or it could be Carl, and then Becky, and then David, on and on and on for 24 different possibilities. So if the problem is not asking for the sample space, if it's only asking for how many possibilities, I can just use multiplication. I have to think about how many different actions there are, and I have to think about whether the number can repeat or not. And then I multiply. You are going to be doing your own problem on the Google Slides, and it is called the Chipotle problem. So a few years ago, I was at Chipotle. I was enjoying my burrito. I was drinking my soda, and I saw that on the cup, it said that there were 60-some thousand combinations of what you could order at Chipotle. Okay, guys, so I want you to use the information from this video to solve the Chipotle problem, to tell me how many different combinations there are to order at Chipotle. Here's some information. When you first go to order, you have to choose between a burrito bowl, a soft taco, hard taco, or salad. And then they ask you what kind of meat you want. You can choose chicken, steak, barbacoa, carnitas, or you could choose no meat because maybe you're a vegetarian or you just don't want any meat that day. You then have to pick either pinto beans, black beans, or you could also pick no beans. Then there is rice options. You can choose white rice, brown rice, or no rice. There's 4 different salsa options. And then there's a bunch of other things that I can add on to my food if I want to. So my question is, how many different combinations can you order? Show your work and label everything or explain it on a piece of paper. And then you're going to include or take a picture of that paper and put it on your slides. We need to know, is there really 60-some thousand, or is there less, or is there more? Talk to you guys later. Bye.